Alrighty, folks. So, today we're moving on to section 2.1, and moving on to chapter 2 in general, which is largely about displaying data. Displaying and presenting data that we've gathered using stuff from last section. And that's what most of the things in this chapter are about, are different ways to do that, starting with 2.1, which is about frequency distributions. Right, so a frequency distribution is pretty simple. It's just a two-column table where you have your classes on one side. So maybe this is, we'll go with this one as a pretty simple example. Right, and so you have your classes on one side and you have your frequencies on the other. And so if we wanted to read this table, what it would tell us is that 5 students got an A, 7 of them got a B, 6 of them got a C, 3 of them got a D, and 1 of them got an F. Really, this whole section is just about coming up with, or the correct ways to create these frequency distributions. So generally, all we're going to be doing now is we're going to be doing some problems, right? And both of them, we're gonna work through 2. One of them I'm going to go a little slower because I'm sort of going to be reintroducing these vocabulary terms as we work through it, and then the last one we're just going to sort of chunk it out using the stuff we've already talked about and go through it pretty quickly. So for the following 2 data sets, we're going to find a frequency distribution, including relative and cumulative frequencies. And we also want to find the class boundaries and midpoints. So this first step here, finding the frequency distribution, the book breaks that down into 3 different pieces. 3 different pieces. Maybe 4. We'll go with 4. So first you need to know how many classes. And the reason why it's 3, maybe 4, is that we're generally going to skip that one. For this class, you will generally be given how many classes you want to construct your frequency distribution with. When you get out into the field, if you use this in whatever your major is, then your specific disciplines will generally have some guidelines as to how many classes to break it down into. But for our purposes, that's going to be given to us. So once we know how many classes, find the class width. Then we're going to find the class limits. And then we're going to count the frequency. So we're going to hop in with our first data set. So let's see. Okay, so we have 12 pieces of data here, and we want to split it into 4 classes, right? So one of the key things about figuring out the class width, right? So we've been given this one. Next one is to figure out the class width. And the key idea there is that we want all of these things to be the same. We want all of our classes to be equally spaced apart, right? And so if we want to know how wide to make something, when we know we need to fit 4 of something of that exact same width into a particular space, we need to know how big our space is, right? If you had a, I don't know, 2 foot long desk and you wanted to be able to fit 4 picture frames that are the exact same width on that desk, well, you'd need to know that it was 2 foot, and then you take that 2 foot and divide it by 4, and that's how big of a picture frame you could get. So we need to figure out how wide our desk is, basically. And so we do that by finding the smallest number, which is that 25 there, and the biggest number, which is that 70, and figure out how far apart they are. Right, so they are 45 apart, and if you want to figure out how big something can be and make sure that we fit everything in there, then we want to divide it into 4 pieces. So we're going to divide that number into 4 and get 11.25. Now, one of the things we also need to consider when we're doing this is what we're doing is building a display of our data. We're trying to present this to someone else, and we need it to look as presentable as possible. And generally, the more decimals you got to put on something, the more digits in general, the less presentable it is, the less easily digestible it is. So, what we're going to do, and what we're always going to do in a case like this, is we're going to round up. Right? And so the reason why we want to do that is that we'd rather have too much space for our numbers. We want to make sure that they all fit in there than have not enough, right? And so if we round down, we might not have enough space because we're taking everything and we're shortening it by a little bit. We've taken what we thought we would have to have and shortening it by a little bit, right? But if we round it up, then we're taking what we know we have to have and adding a little bit more to it. So while it's definitely going to overhang a little bit, we know that it's going to fit, right? So we found our class width. That's the first real step for finding the frequency distribution. And with that, we can start to set up our classes. Whoop, I don't know what I was spelling there. Right, so we want to start, in this case, 25 is a pretty nice round number. So we'll start with 25. Right, and then our class width is 12, so our next class needs to be 12 more than that. If I can write the correct thing, that would be lovely. And our class width is 12, so our next class needs to be 12 more than that. And our next class needs to be 12 more than that. All right, and then we never want any of these classes to overlap. So we do this, right? We also want our upper class limits to match up with that class width as well, right? So this was step 3 of this labeled here. These are our class limits. So this is our lower class limits, and this is our upper class limits, right? So next on our list was to count the frequency. So we need to figure out how many of our data points are between 25 and 36, right? And I'm going to go ahead and check them off as we do so, so we make sure we don't count anything twice. So we have 1, 2, and I think that's it for our first class. Right, so next we need to count how many data points are in between 37 and 48. I believe that is 1, 2, 3, and 4. Almost forgot that one. So we've got 4 there. I'm gonna, just for ease of checking later. Right, so we've got 4 there. Next, we need to count how many are between 49 and 60. So I think 51 is the only one there. I think everything else is going to wind up in that highest limit. So in between 61 and 70, we've got 1, 2, 3, 4. 5. Right. So, and I knew there was going to be some issue there, because one of the things that needs to happen is if we add up all of them, we should get the number of data points that we started off with, right? We started off with 12 data points. We want to evenly divide these in 4 different buckets. So however many we put in the buckets better add up to 12, right? So now we have our frequency distribution for our first problem. But this says we also want relative frequencies. So relative frequencies are very easy to get. You take your frequencies and you divide them by this total. So to get the relative frequencies, we take our frequencies, whatever we got here, and we divide it by the total number of things, right? So we'll get more into this, I think, in the next chapter. But really what we're saying there is that if you pick one of these data points at random, there's a 1/6 chance that it's going to be between 25 and 36. There's a 1/3 chance that it's going to be between 37 and 48. There's a 1/12 chance that it's going to be between 49 and 60. And there's a 5/12 chance that it's going to be between 61 and 72. So that's really what relative frequency means there. Cumulative frequency. I'm going to wish I had more room here in a second. Just means to sort of keep track of how many have there been so far, right? So there have been 2 so far here, but there have been 6 so far there, right? Because there were 2 in the lowest class, and then we take the 4 that we got from going to the next one, and we get the full thing. There's going to be 7 here, and your last cumulative frequency is always going to be equal to the size of your sample, the number of data points that you have. Right? It's also 7 plus 5, so our work checks out. So that is our frequency distribution. It has relative frequencies and cumulative frequencies. Right? So cumulative just means keeping track of everything that came before it as well. Right? So not just each individual class, but each individual class and everything that came before it. So boundaries are a little bit tricky. I'm going to continue this table. So ... We're going to have boundaries and midpoints. So boundary just means figuring out sort of halfway between the upper and lower limits here, right? So halfway between 36 and 37 is 36.5. Halfway between 36 and 37 is 36.5. Halfway between 48 and 49 is 48.5. And we get it here too. These do always overlap. The upper class boundary of 1 and the lower class boundary should always be the same. So halfway between 60 and 61 is 60.5. And so the trickiness kind of comes with that 25 and that 72, right? Because technically that there's nothing to compare it to, right? Nothing to get halfway between. But we notice for all of these, what we did was we added 0.5 to the upper boundary and we subtracted 0.5 from the lower boundary, right? So since that's what we did for all of these in here, and if we calculated our classes right, it's always going to be the same thing for all of them, then that's what we can do for these two as well, right? So once we do it using the halfway between trick enough times, we can maybe figure out what a different sort of rule is and use that different sort of rule for those ones where there's no halfway between. So midpoints are also a halfway between sort of thing, though it's a little bit harder halfway between. These midpoints are going to be halfway between the two limits of the same class. Right, so 25 plus 36 over 2. That's how you get halfway between, if you hadn't seen that before. And so we get 30.5 here. Right? For the second class, we take the lower boundary and we add it to the upper boundary and we divide it by 2. Alrighty. Same for this one. We take the lower limit and we add it to the upper limit and we divide it by 2. And same for the last one. We take the lower limit and we add it to the upper limit and we divide it by 2. So that gets us our frequency distribution with relative frequency, cumulative frequency, our classes with their upper and lower limits. Then we also have the boundaries of all of those classes and the midpoint of all those classes. Right? So that's all we got for that particular set of data. So we'll do another one. Okay, so here we have 9 different points in our data set. Let's see. Do I want to stop? No, let's not stop at 9. I'm gonna throw some more data here. One more row. There we go. Okay, we have 15, and I say we want to divide it into 5 classes. Right, so our process is going to work out exactly the same way. First, we need to figure out what the class width is. So to find the class width, we need to know the total width. So we need to find the smallest number, which is here, and the biggest number, which is here. Oops. Yep. So we get that the total width of everything is 22,500. And we know we want to separate it into 5 classes, so we need to divide this by 5. So when we do that, we get 4,500, which is not too bad. It's pretty round, all things considered. But again, we need to keep in mind that this is done to show off some data, right? So we want to make it sort of as nice as possible. So I'm thinking we want to round to 5K for the class width. And one of the nice things that does is it means I can write all of our data in terms of Ks and have a lot less writing to do, and that's one thing I like to do. And keeping that in mind, right, last time we started our classes at the lowest data point, right? 25 was the smallest data point, and that's where we started our classes. Here, we've got some way too big numbers with way too many digits, and I don't really want to start at 10,200, so maybe I want to also round my lowest class boundary, or class limit, my lower class limit, to 10,000. And in fact, let me take all that back. I'm going to write it as 10K. Because I would like to have room to finish this problem. So 10K That means this is going to be 15K, 20K, 25K, and 30K. Right? And then, unfortunately, this next bit is not going to be quite as nice. Can't do anything about that. We already simplified as much as possible, and there would be no way to simplify every single bit. So we got there. Right? So it's the next number before the previous boundary, right? And we can see that each of these also goes up by 5K. Right? So our upper class limits also go up by 5K, which is good. That's what we want. Now we need to count. Right? So in between 10K and 14,999, we have 1, 2, 3, 4, 5, 6, it looks like. We'll see if I miss any later. Between 15K and 19,999, we have 1, 2, looks like. Between 20K and 24,999, we've got 1, 2. Between 25K and 29,999, we've got 1, 2, 3. And 30K and 34,999, we've got 1, 2. And so if we add all these up, we see that that makes 15, which I believe is how many we started with, so good, right? That's not necessary for frequency distribution, right? This part here is not actually part of the frequency distribution. It's just to check our work, right? Though it does make this next bit easier, right? Because remember, relative frequency is just taking the frequency and dividing it by the total. So we've got 6/15, 2/15, 2/15, 3/15, 2/15. We can take a 3 out of some of these, so we get 2/5 and 1/5, but that's about as simple as we can make it. Right, and then cumulative frequency, we get 6. Then the next row adds 2 to that. The next row adds 2 to that. The next row adds 3 to that. The next row adds 2 to that, and it winds up being the same thing as that there, which again lets us check ourselves, right? When we do the cumulative frequency, we always want to wind up with that last number being the total number of data points that we had. Alrighty, so this is how you build a frequency distribution, right? It's a lot about how we want to display this data. The whole class width is a difficult word to say with anything else. The whole class width issue is to make sure that we're being honest about things, right? If we had one bucket that was just twice as big as the other, then how many it has compared to everyone else is less meaningful, right? So we want all of our classes, all of our buckets to be the same size. And then instead of having to look at this whole big list of data, which admittedly is a lot worse now that I've scratched out everything, it's a lot nicer to just know, well, there's 6 of them that are in between 10,000 and 15,000, and 2 that are in between 15,000 and 20,000, and so on down the list, right? So it's a nice simple, quick, and easy way to summarize big, long lists of data. That's a nice one to sort of get started with. Next section, we'll be talking about all sorts of different types of graphs. We'll be drawing some pictures. We'll be talking about when various different ways of displaying it will be useful. But that'll be for next time.